Hey guys, today we've got a new set of notes about covalent compounds. We've been learning about ionic, now we're going to move on to covalent. If you remember from types of compounds, covalent compounds are created when two anions cooperate and share electrons. This makes sense because anions are negative, which means they're looking for more electrons. So if you take two things that are both looking for more electrons and put them together, no one's going to give anybody anything. They're just going to have to make do and share with what they have. So because they are sharing, they're not transferring, we do not have to balance ionic charges. We don't have to deal with that. The whole crisscrossing method we were doing the other day, or balancing out to zero, none of that applies with covalent compounds. Covalent compounds can be made of lots of different numbers of elements. So to figure out their formulas, we have to use these things called prefixes. You probably didn't think you'd get an English crossover in this video, but here it is. A prefix is something that goes before a word, which hopefully you've learned at some point in English. And we're going to be using numerical prefixes. So those are prefixes that indicate a specific number. They're listed here in this lovely table. For one, you've got the prefix mono, like monorail, trains run on one rail. Two, you've got di, like dichotomy, if you know the word dichotomy. Three is tri, which is super familiar because of like tricycles, triangles, that sort of thing. Triangle is three sides, tricycle is three wheels, tri means three. Four is tetra. That's going to be one that is really unfamiliar and it'll probably be hard to remember, so think a lot on it, study that one. 5 is penta, like pentagon. 6 is hexa, like hexagon. 7 is hepta, like heptagon. 8 is octa, like octagon. 9, nona. 10, deca. Deca is like decade or decathlon. It means 10. So a lot of these are really familiar from geometry, which will hopefully help you remember them. The ones people usually forget are tetra and hepta. Tetra and hepta are the most missed, so those pay particular attention to. When naming a covalent compound, you'll use these prefixes. When you're writing the formulas, you'll find these prefixes in the names to help tell you the subscripts for your formula. So they're really useful and you need to know them. These will appear before the word for each element in the compound, but there is an exception that you need to know about. We only use the prefix for mono, for one, if it's on the second element in the atom. We'll see an example of that below. We're going to go over naming covalent compounds, and then we'll look at some examples of covalent compounds. In naming covalent compounds, you write the name of the first nonmetal, because there's two nonmetals, and you give it a prefix unless there is only one. If there's only one of whatever the nonmetal is, you don't use a prefix, you just write it down. And then after you do that, you write the name of the second element, but you have to change the ending to IDE, just like we were doing with nonmetals in covalent compounds. And you do include a prefix for this one. Let's just go ahead and look at an example down here. This number 1, which is S for sulfur, F for fluorine. Sorry, trying to adjust my page. All right, so this one starts with sulfur and ends with fluorine. Those are both nonmetals, so this is definitely covalent. To name this compound, this one right here, we write the name of the first nonmetal. That first nonmetal there is sulfur. So on the line, I'm going to write sulfur. It says if there is only one, don't use a prefix. There is only one sulfur there because it doesn't have a subscript, so just leave it as sulfur. And move on to step 2. Step 2 says write the name of the second nonmetal, but change the ending to IDE. Add a prefix indicating the number of the subscript used for this element. So the second element here is fluorine. If we change the ending of fluorine, we get fluoride. I'm going to leave room for my prefix. Fluoride. And then we have to add a prefix indicating the number for the subscript. The subscript there is 6. That means we're using 6 fluorines. Go up here, look at the handy dandy chart. 6 is hexa. So So I'm going to go add a hexa prefix here to my fluoride, and it is hexafluoride. So I'm just going to slip that right there. This is sulfur hexafluoride. Let's move on to the next one. N2O4. According to the steps above, we write the name of the first nonmetal. Name of the first nonmetal there is nitrogen. So I'm going to write it down. If there's only one element, don't use a prefix. There is two of the element, which is more than one, so we have to add a prefix. The prefix for 2, if you go look up here, is di. Di. So I'm going to go down here, and in front of nitrogen, I'm going to add the prefix di. Dinitrogen. Moving on to step number 2, we write the name of the second nonmetal, which is oxygen, but change the ending to IDE. So it's going to become oxide. And we're going to have to add a prefix. So I'm going to write it kind of further over. Got oxide. The subscript here is 4. So we've got to go look at the prefix for 4. Prefix for 4 is tetra. So down here in front of oxide, I'm going to put tetra. T-E-T-R-A. This is dinitrogen tetraoxide. Go ahead and pause the video. Try to do the next 3 examples. I'm going to stop writing them out, so whenever you play, you can have the answers to check. Make sure you're doing everything correctly. All right, go ahead and check to see that your answers are correct. If they are, move on. If you got things really wrong and you don't know where you messed up, email a teacher, come to office hours. We'll help you get it figured out. Now over here on the other side, we've got some names that we're going to change into formulas, starting with trinitrogen monoxide. Trinitrogen is the element nitrogen. You can see the word in there. So write N for nitrogen. And this prefix, tri, is going to tell us the number of atoms of nitrogen. So tri is up here. There's tri. It means 3. So I'm going to put nitrogen with a little 3. Monoxide, that is oxygen. You can kind of see the OX in there, and we changed the ending to "ide." So that's going to be an O. Mono is the prefix for, let's go look at the chart. Mono is the prefix for 1. So we leave just 1 oxygen there. Scooting down to number 2, you've got diphosphorus pentoxide. Phosphorus is a P. And it's got that di prefix. Di, if you go look up here at the chart, is 2. Di is 2. So the subscript down there for P is 2. Moving on to the second word, we've got that oxide again, which comes from oxygen with the changed ending. So write O. And the prefix is pent, which came from penta, which if you look up here is 5. So that one's going to be P2O5. Go ahead, pause the video again, try these next 3, see if you can do it. Hopefully you'll get the answers right. All right, and there are the answers. Please note that for covalent compounds, we did not use charges at all. We only used prefixes. So anytime you're dealing with covalent, you don't have to do any balancing charges. It's not something you need to worry about. And that's because covalent compounds aren't transferring those electrons over. They are sharing the electrons between them. And once again, I just want to show you a quick resource. In your Google Classroom, you have this awesome thing called the Compound Interactive Tutorial. If you go open it up, the first thing that you'll see is this page. It'll say, "What are you doing?" And you do have to click present and go into the PowerPoint to be able to do this. But it'll say, "What are you doing?" And you write what you're doing. If you're trying to write a formula, you click that. If you're trying to write a name, you click that. If you need to know what the type of compound is, you click that. Just click the thing, and it's going to take you to a new slide demonstrating what you're trying to do. So say we're trying to figure out what type of compound something is. You click on that, and it's going to take you to a new slide. It's a link. It takes you to the other slide. That's got a handy-dandy chart that tells you all the different compound types. You've got ionic, you've got base, you've got acid, you've got covalent, which we were doing today. It'll tell you what it starts with, what it ends with. And if you click on these other links, it'll tell you how to write the formula or how to write the name. So if you're trying to do this today and it's not making sense, you can come here, click on formula writing for covalent compounds. It's going to take you way over here to formula writing for covalent compounds. It's got the steps, it's got the prefixes, it'll have everything you need. So all you got to do is use this tutorial to find your information. If that doesn't work for you and you have zero clue what you're doing, you're always welcome to come to office hours, shoot one of your teachers an email, and they'll help you figure it out. You should have a covalent compounds practice located in Google Classroom to do alongside your lab. So please go get that done. Complete it today. If you got any questions, let us know.